All right, so I just got an email back from Professor Keith Ellenberger about the behavioral perception difference of the perfect fifth and perfect fourth music intervals with the octave and the root tonic. And I was responding to his article about the evolution of music, and he mentioned absolute pitch. And I posted a video before, but I deleted it. All right, but I didn't upload it. I deleted it because his response really inspired me to do some deeper digging. And essentially, I had already done a blog post. He was asking me about my background and why I was obsessed with this topic, like he is. He said, he admitted, he's so the as I had mentioned in my email to him, or I had done it as a blog post, but they've discovered that tonal languages actually have absolute pitch to the fundamental tone or the root tonic, like the Cantonese or Vietnamese, the more of the Asian languages. They've discovered, like, when they're speaking on different days, they use the same exact pitch. Whereas in the phonetic languages, the change in tone is just for semantics. So you increase the frequency if you're asking a question, and and so what they're trying to study why people who speak tonal languages have better absolute pitch. But this was a question somebody asked me in the comments section, so I was following up on this. And what they've discovered is that there is a direct connection between language and absolute pitch, in the sense that it has to do with the time, how fast you process the time of the frequency. And so that's the time processing is left brain dominant compared to frequency being right brain dominant. But so in Western science, we have an inherent Fourier uncertainty or time frequency uncertainty. And in a sense, you can see this as a physiological uncertainty between the left and right brains. And so my argument that I've discussed with, like, Professor Manfred Euler, who's a physics professor, about how the right and left hearing is like an acoustic spectrometer that's like exhibits the quantum non-locality due to the phase coherence between the right and left ear. And this is what Dr. Man-Wan discussed also in the quantum biology, that not only are we in a quiet room are we able to hear amplitude that's smaller than the diameter of an atom, but when we listen, that what they've discovered with absolute pitch is if you listen just with the right ear only, then your sense of absolute pitch is much better. And then with the brain studies, they've actually shown that the left side of the brain that processes timing is larger in people with absolute pitch. And then they proved that if you start music training before the age of 4, then there's a 40% chance that you'll develop absolute pitch. But if you start training after the age of 6, then your chance of developing absolute pitch just plummets, next to nothing. So it's just a huge difference. So this has to do with the hard wiring of the brain to develop absolute pitch. But on the other hand, they've shown that it doesn't help necessarily in music, because music is based more on relative pitch. But there's something also called the Levitin effect that shows that absolute pitch exists on a subconscious level, because people sing happy birthday around the world starting on the same pitch, whether they try to or not. And other like popular folk songs or whatever, or Daniel Levitin discusses this in his book I read like 15 years ago. So at any rate, the Professor Keith Ellenberger argues this perspective of an inherent symmetry to music as a binary sequence from the octave. So you have this y equals 2 to the x as the basic octave binary sequence. And so he cites a study showing that if somebody, talking about these behavioral perception differences, if it was a study from like 1912, if somebody has played a overtone that's a 3, and then a overtone that's a 2, and then an overtone that's a 3 again, they want it to resolve back to the 2. And they can demonstrate this for all the overtones, where they always want it to resolve back to the equivalent of the fundamental pitch as the root tonic in the melody for the fundamental tone. But the question of whether that means it corroborates the symmetry of the octave is what I was challenging. And so what I was pointing out is that there was this big debate between Helmholtz and Koenig, and Koenig argued that you cannot hear the phase shift of the second and third overtones compared to the fundamental tone. And so when you look at the Fourier spectrogram as an amplitude of the frequency, then there's a dramatic difference when you have a phase shift, because on the one hand, the overtones are self-amplifying, and on the other hand, they're canceling each other out. So it turned out that some people could hear the phase shift, and so Helmholtz, he argued that this ability to hear the phase shift is because of the partials of the overtones. So it's not just the direct overtone, but it's the secondary overtones. So it turns out the perfect fourth has the root tonic as the second overtone, or the third partial, or is it the third overtone or second partial? I can't remember, but it's basically after the octave. It's the root tonic, and then the root tonic has the perfect fifth, but the perfect fifth does not have the root tonic in the overtone series, which is pretty weird when you think about it. But what this means is that in the Indian music tuning, they point out if you have a drone, it's not necessarily the highest note that it's not necessarily the lowest note that is perceived as the fundamental pitch if you have two notes, because if you have a perfect fourth, then it will, even though it's the higher note, it'll be perceived as the fundamental tone, because it has the root tonic in its overtone series, and yet the root tonic does not have the perfect fourth in its overtone series, and so This is what Alon Kans argues is the inherent noncommutativity to music. So it's an asymmetric time that's infinite and non-local. And so he points out with the Pythagorean comma, you can't just symmetrically divide it back into the octave, because the seventh chromatic note of this 12-note scale is the perfect fifth. And so when you have the normally they add together the exponentials, so it would be 3 to the 12th as 2 to the 19th. But what that's actually doing is taking the perfect fifth as a music interval. So it'd be 3 halves to the 12th against 2 to the 7th as the octave. And so when you just take to the 3 halves and you move the 2 over and add it to the 2 to the octave, what you're doing is you're covering up the fact that the 3 halves actually has a negative, a non-commutative inverse exponential of the 2 as a perfect fifth, which means it's 2 to the negative 1 for the 3 halves ratio. And then you can conversely, you can say that the perfect fourth in the Pythagorean tuning is actually derived from 2/3, so that the 3 is also a negative exponential, or an inverse non-commutative exponential. It'd be 3 to the 1/2, or 3 to the -1. And so then, or not 3 to the 1/2, but 3 to the -1. Okay, so that's the inherent inverse, or a non-commutativity to the music, to the perfect fifth ratio. And so that's actually verified in the overtone series, as Helmholtz argued. He probably didn't realize they were non-commutative. But this was my claim in my master's thesis on sound current non-dualism. I didn't explain it as non-commutative explicitly. I was just saying that it's a dialectical reversal as indeterminate reflection based on the overtone series of the perfect fifth and perfect fourth. And then I said that this causes an infinite process of resonance with the based on the zero beats of the octave being a non-locality. And so I called it a non-dualism. So I called it sound current non-dualism. So the 0 beats of the octave is based on the secondary order of types in terms of logic. So you're not just comparing the intervals directly, but you're comparing the overtones and undertones being non-commutative as resonance, non-local resonance. And so then just reviewing my research in response to Professor Keith Ellenberger, I noticed that the latest research on this ability to hear the phase shift of the perfect fifth and perfect fourth as a undertone of the octave, which is actually a perfect fifth as time reversal phase shift. They just said it's a group delay. The latest research has discovered that that's actually due to a group delay in the recording process. So you have these different, the octave overtone will cancel itself out in a group delay, and therefore you don't hear that difference in the perfect fourth as the reversal, as an undertone of the octave, as a perfect fifth undertone of the octave. But what the Nicholas Solomonsky, the music theorist, he argued in the article I cite, the perfect fourth as a phantom tonic, is that in fact, because the root tonic is in the overtone of the perfect fourth, and and therefore, but the root tonic is not in the overtone of the perfect fifth, and therefore the perfect fourth is actually the it's heard as the root tonic. It's the real phantom tonic of the fundamental tone. And so this means in our behavioral perception we have this inherent infinite non-commutative listening process that's also non-local. And since the latest experiments have just explained this away as a group delay, then what we can do is look to the research of Gunter Nimms, the physics professor, and I have his book on superluminal signals, and he's even stated that these superluminal acoustic signals are an everyday phenomenon or phenomena, to quote him directly. They're normally imperceptible, but the thing is that the whole point, the whole debate is whether you require a square wave for a digital signal, because it goes back to Professor Ellenberger arguing that the music is inherently a binary sequence of the octave as y to the 2x, and the limit of the Hilbert space in quantum signaling is the same exponential function, and this is why physics professor Alon Khan, or math professor Alon Khan, says that the spectrogram of the music series, due to this exponential growth, is actually a geometric dimension of zero. It converges to zero, but it's never zero because of the noncommutativity. And this is why you have the Heisenberg uncertainty principle of position and momentum, because when you have an external observation of position of a particle, then you inherently have an uncertainty due to this non-commutative non-locality. So the mathematics assumes that the amplitude as the pressure wave or energy for the probability, the amplitude squared, cancels out all the negative frequencies in the non-commutative matrices. But the non-commutativity is inherently due to the inverse exponentials as the undertones of the time reversal. So in fact, you don't need to cancel anything out. You don't need to use probabilities. You don't need to use the wave function, because the wave function assumes this symmetric space-time. So Gunter Nimms is pointing out that you can have a phase velocity signal that's superluminal, just as Louis de Broglie also realized for his law of phase harmony. So it's within the group wave itself as a group delay, but then so in other words, you can hear the difference between the undertone and the overtone due to this superluminal phase velocity signal that's inherent. It's inherent to reality because it's non-commutative mathematics. And so this is also the point, the emphasis of Nobel physicist Gerald de Hooft in his article he co-wrote with Martin van der Mark, who passed away a few years ago. But their argument is like, if you take the gravitational mass, it's assuming a center of gravity measurement that's a symmetric geometrical mean that Newton, it was documented in the 1960s, Newton derived that inverse square law directly from the music theory. The inverse square law is from the geometric mean symmetry from music theory. So in other words, their argument in their article "Light is Heavy" is that the photon as light inherently has gravitational mass, but it's not based on the center of mass as an average of a box. Like, you have to assume you're measuring the light as contained in a box, but the actual gravitational mass of light is inherent to the momentum defined by the frequency and not defined by the squaring of the wavelength. So this is precisely the same point of Alan Kahn and and Gunther Nimps with this superluminal sound signal, as he's relying on the phase wave being a pilot wave from the future as a time reverse signal. And therefore, you can have he can send Mozart as a superluminal signal based on a negative refractive index that has quantum tunneling from the future. And, he sets up two crystals to do this, but then he says that that kind of group delay due to the negative refractive index, it's ubiquitous in our everyday environment. And so it's normally imperceptible, but if we scrutinize our listening, we'd be able to hear that superluminal signal as an echo from the future. But Alan Kahn, he's taking that to a deeper level, and he's saying the mathematics itself explains that reality is non-local as noncommutativity, based on this future and the past overlapping, and this is Professor Basil J. Hiley's emphasis as well, is that you don't have to use probability, that the quantum algebra itself is non-commutative. And so the matrices, this is Alan Kahn's point, is that the origin of quantum randomness is actually from this negative entropy in the matrices based on this invariant non-commutative ratio that he just calls, 2-3 infinity, because that's the simplest way to explain it, is by using music theory with the discrete rational numbers. And so I had never made the connection before that the phase shift, what I was calling the Hempel effect, that the latest in science had dismissed it due to a group delay. But if you look at Gunther Nimps' superluminal sound research, where he recreates this superluminal Mozart signal, he's saying that the group delay is actually due to a time reversed phase velocity, that's superluminal phase velocity, and it's only by assuming Lorentz invariance in relativity that you're assuming a square wave signal limit. Whereas if you just rely on frequency directly using sine waves, or what they call sine waves, but you don't define it as a symmetrical sphere for measurement. It's rather a quantum block sphere that's non-commutative. So it cannot be observed visually, but it's faster than the Fourier uncertainty principle. And so this is why it can be accessed through meditation directly as quantum biology, but it's not normally measured in science due to the inherent incorrect mathematics that's assuming a symmetric space-time invariance instead of a invariance as a non-commutative ratio that Alan Kahn's assumes. And the Pythagoreans assumed, if you properly understand, or the Taoists, or the three gunas of India, is the secret of Neigong alchemy, as Eddie Oceans realized for quantum psychology. And it also explains negative entropy and gravitational entropy increasing due to trying to decrease the entropy of matter using this symmetric equipartition principle in statistics. So it shows that the language of science is based on math, but as math professor Luigi Borzacchini points out, this was a deep, pre-established deep disharmony, a deep pre-established disharmony in the symmetric mathematics. And so Lacan even argued that the noncommutativity explains the paranormal as Jungian synchronicities. It's precisely that the Wolfgang Pauli spin physics are inherently non-commutative, and that's what creates these seemingly acausal synchronicities, is that they're due to a formative cause and not a primitive time causality that assumes a linear time observation in symmetric space-time, limited to the speed of light. That's defined again by this symmetric acceleration principle. So that's I'm just going to thank Professor Keith Ellenberger for inspiring me to find that connection between the group delay explanation of the perfect fifth phase shift and the superluminal sound signal that Gunther Nimps documented due to the same group delay phase shift that actually requires a superluminal phase velocity, the phase signal. So there you go, and we can tie that back to absolute pitch if we want to, but there's a deeper level of perception also. And thanks for letting me spew that into the interwebs.